We are into chapter 3 and section 3.1, which is functions. So we're going to determine whether relations are functions, find the domain and range of a function, and identify the independent and dependent variables of functions. So first thing that we want to write down here is this important part right in here, determining what a function actually is. So we have a relation which pairs inputs with outputs. When a relation is given in ordered pairs, the x-coordinates are inputs and the y-coordinates are outputs. The key thing here is understanding what a function is. A relation that pairs each input with exactly one output is a function. So in simpler terms here, we cannot have repeated x values, okay? So each x value goes to exactly one y value. So like I said before, in simpler terms, we cannot have repeated x values for something to be considered a function. Okay, no repeated x values when we're determining if a relation is a function. So let's take a look at our first example here. It says determine whether the relations are functions and explain. So what we're looking at when we're dealing with these problems here is we're looking and we're determining, do we have any repeated x values? Okay, do we have any inputs that are going to, or any inputs that are repeated here? So we're looking at our x values. We're looking at these guys. Okay, -2, -1, 0, 1, and 2. Nothing is repeated here. So yes, our first example is a function. You'll notice here I have repeated y values, right? I've got 2 that's repeated and I've got 0 that's repeated. That is perfectly fine. Your y values can repeat, but your x values cannot repeat here. So this is a function. Let's look at our second example. Looking at the x values, we've got 4, 8, 6. We've got a 4 and another 4 here. So in this case here, no, this is not a function because we have a repeated x value of 4. Okay? Let's look at our next example. Once again, the first examples they showed as ordered pairs. Now they're showing as a table. Okay? If we look at this table here, once again, we can see that we have repeated x values here. So once again, no, this is not a function because 0 repeats in the x's. This last example down in here in D is what we call a mapping diagram. Anytime you're given a mapping diagram, I suggest that you either write the ordered pairs that correspond with it or you create a table. I'm going to create a table because it'll be a little bit easier. So I've got my x's and my y's. Here are my x values in blue and my y values are in red. So I know my first point or my first coordinate would be -1, 4. Then I have 3 going to 15, so 3, 15. And I have 11 going to 15 as well. So once again, I have repeated y values. That doesn't matter in determining if something is a function. I'm looking if I have any repeated x values. I do not. I have -1, 3, and 11. So yes, this is a function. For the same thing, we have no repeated inputs here, no repeated x values. So in determining if something is a function by looking at the coordinates or a table, you're looking and determining, do you have any repeated inputs, any repeated x values? Let's look at our next topic that we have to cover in this section, which is the vertical line test. So the vertical line test is a test that you use when you're given a graph to determine if something is a function. So a graph represents a function when no vertical line passes through more than one point on the graph. So if you look at our example on the left, this would be a function, okay? Because if I draw in my vertical lines, you might have heard of it as your pencil test as well. it's only hitting one point on the graph no matter where I draw a vertical line in. If I draw it here, 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 no matter where I draw it in, it's only going to hit one point on the graph. If we're looking at our example on the right-hand side, this example, two different spots on the graph. Because it's hitting in more than one spot, this would not be a function because it fails the vertical line test. Okay, it's hitting my graph in more than one spot when I draw my imaginary dotted line in or I draw my pencil in there. So let's look at an example here to determine whether or not something is a function. So if I look at my example on the left-hand side here, and I draw in my vertical lines, I can see that if I draw in a vertical line right here, it's going to hit in two different spots, there and there. So in this case, in letter A, this is not a function because it hits the graph in two different spots here, and it fails the vertical line test. Here in B, if I draw my lines in everywhere, I'm only hitting in one spot every time. So this one is a function because it passes the vertical line test. Okay? I never hit in more than one spot. Let's keep going into our next topic, which is domain and range. So domain and range is something that you're going to see for a long time in Algebra 1 and Algebra 2, so it's important that you understand this concept. The domain of a function is the set of all possible input values, or x values. So domain goes with your x values, and the range is the set of all possible output values, or y values. And the way you'll remember which goes with which is domain D comes before range R, and x values comes before y. So domain goes with x and range goes with y. And all we're doing when we're determining the domain and the range is we're determining where our function exists. Like, where is our function living in relation to our graph? So we've got two different types of graphs here, one of which we consider a discrete graph, okay, which is letter A. This is discrete. And then over here we have a continuous graph. The difference being in letter A, you'll notice that our points are not connected, okay? While in letter B, in our continuous graph, our points are connected. And that's going to change the way that we write our domain and our range. So the discrete graph is a little bit easier, okay, when we're talking about our domain and range, because we can just list out the values of our points. So our domain here is a list of where does x exist. Well, where does x exist? Well, it exists at this point, at this point, at this point, and at this point. Well, what are these points? This is the point -2, -2. This is the point -1, 0. This is the point 1, 2. And this is the point 3, 4. So my domain, I would just list out my x values when we're talking about a discrete graph. So my domain here would be -2, -1, 1, and 3. Okay, it's just a list of my x values. Oh, sorry, this is -3. Wrote the wrong point here. Let's get rid of that. Okay? Your range is just your y values. So we've got -2, 0, 2, and 4. And we would just list those out. So it's pretty easy when you're dealing with a discrete graph to write the domain and range. You're just dealing with what the points are and writing down your domain as your x values of your points and your range as your y values. The continuous graphs are a little bit more challenging because now it can take on every single value on the graphs. So we want to write these as inequalities. And you want to think to yourself, okay, in terms of the domain, where does my graph begin and end in terms of the x values? Well, here is my starting point. And here is my ending point. Okay, and I want to think about, all right, where is this graph existing here? Okay, what's the most extreme values that it gets to? Well, in terms of the x values here, it's starting at an x value of -2, and it's ending at an x value of 3. Okay, I'm thinking in terms of my x-axis. However, because this is a continuous graph, it can be any single value. It takes on all of the values there. So we want to write this as a compound inequality. Your domain is anywhere starting at -2 and ending at +3. So what we're saying here is we're writing this as an inequality, saying our graph is from -2 to +3, including both of those points. So x is greater than or equal to -2 and less than or equal to 3. I write it as my compound inequality, like shown. In terms of the range, once again, think of your most extreme points on your graph. Well, the lowest point I get to is a y value of -1. The highest point I get to is a y value of 2. So I'm going to go through that same exact idea, writing my range as a compound inequality. -1 is less than or equal to y, which is less than or equal to 2. So all I'm saying here is that my y values go anywhere from -1 to +2. It's important that you have the correct variables here. X for my domain, range, y for my range. The final thing that we're going to talk about in the video deals with independent and dependent variables. The variables that represent the values, the input values, are called our independent variables, okay? Because it can be any value in the domain. The variable that represents the values of the function, or the output value, sorry, is the dependent variable because it depends on the value of the independent variable. You'll almost always see that your dependent variable is y and your independent variable is x, okay? So your dependent variable is y and your independent variable is x because that y value depends on whatever your x value is. So let's take a look at an example here. It says the function y equals -3x plus 12 represents the amount of y in fluid ounces of juice remaining in a bottle after you take x gulps. And it's saying to you, identify the independent and the dependent variables. So like we just said here, your independent variable, or sorry, your dependent variable, let's do the independent first. Your independent variable is your x, which in this case would be the number of gulps. And your dependent variable is your y variable, which in this case would be the amount of fluid, or the amount of juice left. And that should make sense to you because the amount of juice left, your y, depends on how many gulps you've taken, x. So that y variable depends, aka your dependent variable, on your x. So they're telling us the domain is 0, 1, 2, 3, and 4, and they're asking us what is the range. So they're telling us, okay, domain are your x values. These are your x values, and all they're asking us is determine what your y values are. So if you're asked a question like that, you can just go ahead and plug in those x values into your equation to get the y values. So we can create a table if we want. Here are my x's, or my input values, and I have 0, 1, 2, 3, and 4. I'm going to plug them into my equation, which is y equals negative 3x plus 12, to get my y values, which is my output, and eventually my range. So all I'm doing is I'm plugging in those values into my equation. So y equals negative 3 times 0 plus 12. Obviously then, negative 3 times 0 is 0 plus 12. I'll get a y value of 12. And then just continue to plug these in to get your y values here. So we would get a y value of 9, 6, 3, and 0. Those y values right in here are my range. Okay, so your range here would be 12, 9, 6, 3, and 0. We're dealing with something that's considered discrete here because we're talking about gulps. You can't take like 0.3 of a gulp. We're saying you can take 0, 1, 2, 3, or 4. It has to be a whole number. This is a discrete graph, hence the reason why we write our domain and our ranges as just numbers as opposed to an inequality like we saw before. We'll go through lots of examples in class. See you then, guys.